Welcome back to this video series on the logistic regression classification method. Recall that the previous video left off just as we had selected Next on the Step 1 dialog to advance to the Step 2 dialog. Since we have not yet partitioned our data set, we can do so by clicking the Partition Data command button and then selecting the Partition Data option. I'm going to leave the defaults for partitioning options and click Done to close the dialog. Since scaling has no substantial effect in regressions, we will skip rescaling the data and instead click Prior Probability. Analytic Solver incorporates prior assumptions about how frequently the different classes occur. If empirical is selected, Analytic Solver data mining will assume that the probability of encountering a particular class in the dataset is the same as the frequency with which it occurs in the training data. If uniform is selected, Analytic Solver data mining will assume that all classes occur with equal probability. And if manual is selected, the user can enter the desired class and probability value. I'm going to click back to empirical and then click Done to close the dialog. Keep Fit Intercept selected, which is the default setting, to fit the logistic regression intercept. If this option is not selected, Analytic Solver will force the intercept term to 0. Keep the default of 50 for iterations. Estimating the coefficients in the logistic regression algorithm requires an iterative, nonlinear maximization procedure. You can specify a maximum number of iterations to prevent the program from getting lost in a very lengthy iterative loop. This value must be an integer greater than 0 or less than or equal to 100. Select Variance-Covariance matrix in order to include the coefficient covariance matrix in the output. Select Multicollinearity Diagnostics. At times, variables can be highly correlated with one another, which can result in large standard errors for the affected coefficients. Analytic Solver data mining will display information useful in dealing with this problem if this option is selected. Select Analysis of Coefficients. When this option is selected, Analytic Solver data mining will produce a table with all coefficient information, such as the estimate, odds, standard error, etc. When this option is not selected, only the estimates will be included in the output. When you have a large number of predictors and you would like to limit the model to only the significant variables, click Feature Selection to open the Feature Selection dialog. Select Perform Feature Selection. Analytic Solver data mining offers 5 different selection procedures for selecting the best subset of variables. Backward elimination, in which variables are eliminated one at a time, starting with the least significant. Forward selection, in which variables are added one at a time, starting with the most significant. Sequential replacement, in which variables are sequentially replaced and replacements that improve performance are retained. Stepwise selection is similar to forward selection, except that at each stage, Analytic Solver data mining considers dropping variables that are not statistically significant. And best subsets, where searches of all combinations of variables are performed to observe which combination has the best fit. For a more complete description of these selection procedures, please see the Analytic Solver Data Mining User Guide under Help, User Guides. Click Done to accept the default choice, backward elimination, and return to the Parameters dialog. Then click Next to move to the Scoring dialog. Select Detailed Report under both Score Training Data and Score Validation Data, and also Lift Charts. Analytic Solver data mining will create a detailed report complete with the Output Navigator, a report that summarizes the regression output for both data sets, and lift charts, ROC curves, and decile charts for both partitions. Since we did not create a test partition when we partitioned our data set, Score Test Data options are disabled. Click Finish. This ends this third video on the logistic regression classification model. See the next video to learn about the results from this model.